Hi, Miss Marquardt.
Hello, Mrs. Grant.
I have something to show you.
I was gonna say, what do you got there?
Well, do you remember yesterday in science when we melted some crayons?
I sure do.
Well, I have those molds of crayons and they have solidified.
Ooh.
They've cooled and
Uh-huh.
they've turned back from a liquid into a solid.
So
Yes.
it's like they went back into a crayon.
Yes, they did.
How
Yes.
cool is that?
Yeah, so today we're going to talk all about what happened and what happens to something when it freezes and melts, and is that a reversible change or an irreversible change? We're going to learn all about that today.
Cool.
But first, we're going to pop these crayons. I'm going to ask you to hold this, okay?
Sure.
Because I'm kind of nervous.
Okay.
We have these molds here, and if you can see, there's wax in it. And we mixed several different colors of crayons. If you remember from the video yesterday, we had like yellow and blue and a couple different colors that we mixed, melted together, and poured into these silicone molds. So let's see what happens when we pop this out. I'm going to try to be as careful as possible.
Wow.
So, pretty cool. I'm going to zoom in here so you guys can see this a little better. Okay, this is what the crayon looks like, but if I turn it backwards, I don't know if you can tell it's not like a full crayon, it's like half of it because the molds are quite a bit larger than our original crayons were. So we have a couple of like half molds that I guess we could put together if we wanted to make a full crayon. But I'm noticing that now that I like how it says twig on it.
I know.
For twig
I saw
science
that,
on
twig
our
science.
crayons. Now that they have solidified and hardened again, it's just like a regular old crayon again.
Yeah, it's like we almost didn't do anything to it.
Yeah, that's pretty cool.
Maybe I can put this under the screen too.
Yeah, that'd be great. So while Miss Marquardt is kind of showing you, these are kind of half crayons, like one side is kind of flat and the other is rounded. If you guys could take a minute to draw the new crayons here in this white space provided on page 59 of your science notebooks here. Take a moment to draw it. What would you describe that color as, that all the colors mixed into?
An ugly green.
An ugly green, right?
Yeah, I don't like it.
It's not quite forest green, it's not quite brown, it's kind of like a brownish green.
Yeah, it's almost like an army green. Like,
Yeah.
I should have worn my camouflage
You should've,
pants
yeah.
because they would have matched perfectly.
Yes.
But yeah, I think that if you were to color your body in this and go out into the forest,
Mhm.
I wouldn't be able to see you.
Yeah.
So.
It makes sense though because we did mix blue and yellow, and when
Oh.
you mix those colors, what do you get?
You get green.
Green, but it's not a super pretty green because I think we also had like some orange mixed in there
Yeah.
too. So
We really
interesting
messed
green.
with the color
Yeah.
palette.
But so go ahead and draw the new crayon here. And then we're going to come down here to communicate your information and describe the new crayon. So we know that when it was its original form, when we had a yellow crayon, a blue crayon, and an orange crayon,
Yep.
how would you have described those original ones?
Well, they were definitely hard when you held them
Yes.
in your hand, and they were round.
They were round.
So I don't know, like a cylinder.
A
almost.
cylinder, yeah.
And let's see. So yeah, they were hard. They had a point at the end.
Would you say they were liquid or solid?
Oh, definitely solid.
Solid.
Yeah. That.
Okay.
So yeah, solid. They were hard. They each had their own color. They had a point at the end.
Yes.
They were very waxy.
Waxy,
Made out
smooth.
of- Very smooth.
Awesome.
Yep.
That's a lot of really good descriptive properties. Those were the properties of our original crayon.
Mm-hmm.
Now, let's think about what the crayon looked like. What were the crayon's properties when it was melted? And
Oh. Well, definitely
Got
not hard anymore.
Uh-uh.
It was actually probably soft. I didn't touch it because it was so hot.
Hot, that was a property, huh?
But it looked like water. It was
Uh-huh.
very liquidy.
Liquidy.
And we used all those different colors, and as they were melting, all those colors kind of ran together.
Yeah.
But it was still made out of wax.
Yeah, true.
The wax was still there.
So now you guys need to describe the new crayons. We just described the original crayon and then the melted crayon. Now we want to use those words to describe the new one. Would you say solid?
Definitely solid,
It's
because I
solid.
can hold it in my hand.
Would you say smooth?
Yes, very
Would you
smooth.
say cool or hot?
I'm going to go with cool.
Cool.
Yeah,
Someone said
because it's
cool
not
is
burning my hands.
True. Would you say yellow and blue?
No, I would say ugly green.
Okay. So those are some options of things you guys can write down here. Would you mind pulling this down so we can see the top of page
course.
60?
I might just stay right here to...
Yeah, you can write this in for us. So we're going to complete the sentences now that we've gone through the procedure of taking our original crayon, heating it up, causing it to melt and turn into a liquid, and then cooling it off in its mold, allowing it to return back to a solid form. So, blank causes the solid crayons to melt. What did we apply to the crayons to create to cause them to melt?
Well, we used that frying pan with the heat source underneath.
Heat. Very
All right.
good. So heat, H-E-A-T, causes the solid crayon to melt. When we applied heat to it on the stove, it melted. The solid crayons became liquid wax. If we blank the wax, then the liquid wax becomes solid again. So after we poured it into the molds, the silicone molds, what had to happen? Did they need to heat up more?
Oh, we needed to let it sit like overnight and allow it to cool down.
Cool, very good. So if we cool the wax, C-O-O-L, then the liquid wax will become solid again. Okay, so when you heat something, it melts, and when you let it cool, it hardens into a solid again. Okay, these are reversible changes. Okay, means you can go back and forth. I can turn a crayon into liquid, and then I can turn it back into a solid. It's reversible. We can undo that change.
And that's what we did.
Yes. Solid crayons and liquid wax have different properties. So the properties are the things Miss Marquardt and I were just talking about. How the solid crayon was cool, and it was solid, and it was smooth, and it had a point at the end, and it was round. The different properties of the melted crayon, it was hot, it was liquid, it was kind of a mixture of those colors. There was definitely no point because it was like a pool of wax, of hot wax. So very different properties. Let's come down to the challenge now, and what we have here is a Venn diagram. And in a Venn diagram, you're comparing and contrasting two things. So over here on the left, we have a circle for our solid crayon. And then on the right, we have a circle for our melted wax. And then in the center, where they overlap, are things that are the same whether it's liquid or solid. So let's consider the left-hand side, Ms. Marquardt,
Okay.
the solid crayon. We don't want to overdo it. We just want to maybe list maybe two things
Sure.
that is only true when that crayon was in its solid, cool form.
All right. Well, I think you gave me a couple ideas.
I did.
It's solid.
It's solid.
So I'm going to write down solid.
Uh-huh.
And it was also cool.
And it was cool. Very good. Let's jump over to the right-hand side when it was melted wax.
Okay.
Maybe using the opposite of the terms we used in the left-hand side.
I think I can do that. The crayon was solid, but the melted wax was liquid.
Liquid. Yes. And was it cool?
No, it was really hot.
Hot. Very good. Now, let's think about that middle section, something that is the same, whether it was solid or liquid. A property that remained the same.
The entire time that we had the crayons, they were made out of the same thing.
Which
They were made
was?
out of wax both times.
Yes, that's true. So made out of wax. Or just wax, whatever. Awesome. So if you guys need to pause the video to make sure you get all of these things written down, go ahead and do so. We're going to flip the page and do the last two pages with you now. All right. So we're going to, up here there's some directions. It says, use the models. Label each picture using the words. Here are our options. Liquid, solid, heating, cooling, melting, and freezing. So we're going to go through the stages of what we did when we melted the crayons and then when we cooled them back off to return them to the solid form. So Ms. Marquardt, what should we put underneath the first one?
All right, well, I can see the picture has all little broken pieces of the crayons, and so I would guess that that is going to be solid. Those are the crayons before we did anything to them.
So number one is solid. Okay. All right, number two, you had to apply heat to it, right?
Exactly. So we applied that heat, so I would put heating them here. This is like as if there was a little flame underneath it. They should have drawn the flame.
Yeah, they should have.
That
It
would have
been
been helpful.
Huh? So heating.
So we are heating them here.
All right, and then we move over to number three. And are they melting?
Yeah, you can see, like here, they're heating up and there's little pieces of the
Oh,
crayons
yeah, I can
inside.
see.
But by the time we get over here, all of those hard pieces are gone because they are melting.
Ah, nice. So first they're solid, then you apply heat, number 2. And after you've heated enough, they are melting and they become what over on number 4?
Yeah, this is a good drawing right here because you can only pour things if they're a certain, property. And so this is liquid that is
Awesome.
able to be poured.
All right, so the liquid is able to be poured into the mold. Hopefully you guys are copying these at the bottom of each picture like Miss Marquardt is. And then we're gonna jump down to number 5. Once they have been poured into the mold, what's number 5?
Well, you can freeze them if you
Okay.
wanted to. So you can, if we wanted to put them into a freezer and have, speed the process along, we could do that. So they are freezing.
All right, number 6, what are we left with?
Well, once they're in the freezer and they're freezing, they're finally going to be cooling.
Okay. Awesome. And then number 7, they have returned to their original state of being
Yep.
a solid, right?
Back to being a solid.
Awesome. So, one of the things we've talked about throughout this, I want to focus on the word wall over here: solid, liquid, freezing, and melting. So, the state of being, if something is a solid or a liquid,
Mhm.
those things happen. They are reversible changes that happen whether you apply heat or whether you apply cooling.
Right. That's why we
Heating,
got the
melting,
crayon
freezing, yeah.
back to being a crayon
Exactly.
because it was reversible.
Mm-hmm.
Very cool.
So, like an ice cube.
Oh,
Okay,
yeah.
if I were to put an ice cube out on the sidewalk on a hot day,
Oh dear.
what would happen to it?
It would probably turn into a little puddle.
It would, yes. And if I were to take a puddle of water and put it back into my freezer, what would happen to that water?
Well, I guess it would freeze back into an ice cube.
So I can reverse that all day long.
Yeah.
I can take water and freeze it. I can heat it up and turn it back into liquid. I can freeze it again. Let's think of something else that we could do that with. Can you think of another material besides water or crayons that we could freeze and melt?
Well, I love chocolate.
You do.
Like, love it a lot.
Uh-huh.
And I've actually had to do this before where I've left a chocolate bar in my car and it got really melted and gross and I didn't want to eat it, but I put it into the freezer and it hardened back into a chocolate bar. It didn't look exactly like
Yeah.
the way that it did before, but definitely I could eat it because it was hardened.
Oh, that's cool. So chocolate can do the same thing. It can freeze, it can melt, it can return from solid to liquid and back and forth. One last thing I'm thinking of is maybe juice. Okay,
Ooh.
if I were to take a cup of orange juice and put it in the freezer, I could freeze that orange juice and have like a popsicle. And
That
if
sounds
I
fun.
melted that popsicle, it would turn back into orange
Orange
juice,
juice.
and I can keep going back and forth because it's a
Yeah.
reversible change that I can undo.
That's cool.
Yes. And so that's pretty much it for today.
I love it.
Yeah. Thanks for hanging out, guys.